Do you guys want to make a roller coaster? A fully custom PCG roller coaster where you can make it go up and down and curve however you'd like, and to extend it, it really is just as simple as taking your point, moving it wherever you'd like, holding Alt, dragging out, and then you can make it go down or up or anything. And as you can see, all of the support here will follow, and it does not go any lower. It goes only as low as you want it. Let me show you how to create this, as well as a few nifty new tips and tricks I learned while making this. Let's get into it. To get started, go to Edit Plugins and make sure your PCG plugin is turned on by searching PCG and turning on the Procedural Content Generation Framework, PCG, and restart your engine as needed. But once you have that, we just need two things. The first one is, of course, the PCG graph. So I'm going to grab ourselves an empty graph. It's going to be PCG underscore roller coaster, and we'll need a blueprint for the spline. So right click, blueprint class, type of actor, this is BP underscore roller coaster. Let's open up the blueprint, and here we just need a simple spline component. I'm just going to take this point and kind of drag it out to make it a bit longer. And then I'll add a PCG component, and in the detail panel, I'll plug the graph in that we just made. I'll be using this environment here, the basic world partition one, just because it has a bit of terrain so I can show you how it works with uneven flooring. But this does not require partitioning or anything like that. So you can put it wherever you'd like. Let's go ahead and open up the PCG graph. We're going to get started with kind of two things. One is the main path. The main path consists of the planks that are kind of going horizontally along the entire spline path, and then the two kind of side paths that kind of connect and hold those planks in. Now, I'm going to be using cubes for pretty much everything. I have two cubes here in the content browser. They're exactly the same. The only difference is one of them has a pivot point on the bottom, and the other one is a default Unreal cube pivot point in the center. This is just to show you that you don't need complex shapes. You could just use very basic cubes and create and stretch and turn and do everything you need to just on these. Of course, if you have your own custom shapes, just swap them out and adjust your scales accordingly. Let's start with the main plank track. So I'm going to right click, search for get spline data, and then drag out and grab ourselves a spline sampler. For the mode, instead of subdivision, I want to change it to distance. And now for the distance increment, a default cube is 100 units in length. I want to have a little bit of a gap between, so I'm just set it to 150 to give it a little bit of a gap between each one. So distance increment will be 150, and then I will use a transform points node, and I'm going to uncheck uniform scale. I'm going to scale up to 5x in the width. X is forward, Y is the width, and Z is the height. And the height, I will set it to be something like 0.2. And then it's as simple as doing static mesh spawner with a new mesh entry, and we can plug in one of our cubes right into our static mesh. This one is the regular center pivot because I want it to go out from the center. And now in the world, we can grab our BP roller coaster, drag it out somewhere, and you'll immediately see there's our kind of planks. Very simple setup, nothing to write home about, but let's go ahead and kind of position this somewhere around here, and we can get started with just extending it and having it go up and down. We can even go ahead and actually rotate it, so that way it kind of bends as it goes along. So let's start with this. There you go. So the planks are in. Great. So let's go ahead and get paths on the sides. And the way I'm going to do that is using a spline mesh, so that way it is nice and smooth. You can absolutely do this with irregular mesh, but you're going to get a lot more overlapping pieces. Before that, I'm just going to comment this to be plank track, and then I'm going to grab our get spline data and do another spline sampler. The second one will be also on distance. We'll set it to be something like 200. You can play around with this depending on your mesh and how many divisions it has. You might be able to get away with a longer or shorter distance. A cube doesn't really have divisions in between, so I found that 200 is kind of the pushing point that I would want to put it at. But the main thing is we want to have it on either side. So from here, I'll use a transform points node, and because we've made it 5x in width and it goes off the center, that means we know that the width of it is 500 units. Half of that is 250, so we offset it in Y by 250, and we also offset it in the other direction, which means negative 250 on Y. And from there, we just do a simple create spline, and we create two splines from here, one offset in one direction, one offset in the other direction, and then just a simple spawn spline mesh is all you need. Go ahead and grab that, and then in the spline mesh descriptor, again, we'll plug in the cube. Now, it could throw you a warning here. It says failed to attach the component, check the logs, but I'm not sure why this is, because as you can see in the world, it is fine. Everything is good. And if you click force region in the top left here, the error goes away. I'm not sure what that warning is about, because everything is working and force region makes it go away. Just so you know, it's there. Why, I don't know. And if there's actually a problem, I couldn't find one. So we continue. As you can see already, we have a track here, right? We have the main track, and we have the kind of the side areas here. Now comes the more complicated part, which is how do we get the actual part underneath it? We need to get it to spawn, well, first columns where we need them, and then we want to connect the columns because a regular wooden roller coasters, as you can see, has a bunch of supports, not just the vertical ones, but also horizontal. Mostly they also have some other ones, but for the base one, I'm going to show you how to do the horizontal and the vertical. And then from there, you can go and customize as you want. You'll know the tools and the methods of doing it. I'll first go ahead and just comment this for plank track sides. And now let's get started on the vertical beams. For each one of these, we're still using the same get spline data node. You absolutely can just duplicate this and use it somewhere else. You can also use a named reroute node, whatever's easier. But for the vertical beams, once again, we're using a spline sampler. So I'll go ahead and grab that one. And now we need to choose the distance where we want the beams to appear. Let's go ahead and have them every, let's say, 500 distance. And we want them on either side. So just like the other one, I'm going to just take this transform points, duplicate it, and move it on either side here. It is going to be the same distance, so this works. And then we'll go ahead and just combine them into one set of points for convenience, just like that. So that way we can go ahead and use raycasting. If I drag out of merge points and search for raycast, world raycast, we'll go ahead and select it. And basically this is a line trace. So what we're going to do is trace from these points, which if I sample merge points here, you'll see they're kind of here, but it's hard to tell. So on this merge points, I'm going to change it from extents to absolute. And I'll set the point scale to be something like 1.5. And you'll see there's all our points. So we're going to be basically projecting from these points downwards. So we know kind of where they are. So from the world raycast, we're going to be doing a line trace. It can be infinite, that is fine. Although you can give it a normalized with length to give it a specific distance you want to raycast. I'll keep it infinite for convenience. We're going to be using the position and it is going to be raycasting it down. A couple of things. I'm going to set it to unbounded because we don't have a volume. We need to select unbounded here. Otherwise, if you have a volume, it's within that area, you don't need to. And then under attributes here for data attributes, we can go ahead and get the distance. So I'll go ahead and get that. So if I press A here, you will see that there's all of our points. And if I scroll to the right, you'll see there's the impact distance. That is how far away the ground is from the original point. Now, how does it know to get the ground? Well, over here under filtering, you can see select landscape hits are include. You could absolutely include tag hits or class hits. So you can go ahead and project onto anything with a tag, specific classes, and select whether or not you want to include the landscape or you don't by just changing in here. For me, I'm setting include for landscape, so it automatically grabs it. And this is the default behavior here. The reason we get this distance is because I want to scale the points relative to the distance. What I'm going to do is drag out of this merge points actually and search for set attribute. It's the attribute math operation set. The world raycast is going to go to in B and the merge points is in A. And the reason is on this set attribute, what I want to do is go to point scale because we want to change the scale.z for input source 1. So we're changing the scale of the original points and we want to do it based on the actual distance it's set. And if I press A and scroll to the right, it is called impact distance. So on the set node, I will change it to impact distance. It'll overwrite the scale.z back onto itself. Now note here, this is the full distance of it, but our cube is 100 units in height. So we can just go ahead and divide by 100 to get the proper scale, either later or before setting this value. So what we can do here is use a transform points node, uncheck uniform scale, and scale it to 0.01 in the height. Again, basically dividing by 100, and that will be the scale of the cube. So now if we go ahead and use a static mesh spawner, you'll see what happens. We'll just go ahead and select a cube, but this time I will select the cube that has the bottom pivot. And if we take a look, well, I mean, it is there. It seems sort of correct, but one, it's going the wrong way. So let's start with that. We need to go to the transform points and let's just rotate it 180 degrees on X to flip it around. And you see now that's better, but also it is actually rotating it relative to the original rotation of the point. The distances are correct because you can see they're not touching the ground here, but because the original points were rotated, it is positioning these rotated. Thankfully, that is relatively simple to solve. All we do is before this transform points, I'll grab two more set attributes here, and I'll go ahead and connect them all in line here. For the first one, instead of scale Z, we want to modify the point rotation, but we don't want to set all three axes. We only want to set two. So I'll go ahead and add an extractor, rotator, roll. So there'll be rotation.roll. And on the second one, it'll be the same thing. Instead of .roll though, it is .pitch. Roll, pitch, and yaw. Yaw is the Z axis, which is the one we want to keep because that is the rotation around. But roll and pitch, you want to zero that out. It should be just going straight up and down. And just like that, you will see, hey, there's our planks all going up and down exactly where it needs to. And if I go underground, you can see it stops right at the landscape. So just like that, we have the vertical bars. Fantastic. Now, one thing thing to note though is these are cubes, and depending on how steep or not steep or how angled or not angled your setup is, you'll see occasionally something will stick out either here, or if you have this top area thinner. So if I go on the plank track sides and I scale the height here to something like 0.5 in height, you will see here the cubes are going through it. And there's no real solution here because you can see here it's a little bit too low, here it's a little bit too high, and that's because it is a cube. It is just the shape it is. So the way to hide that is to have the thicker sides so it's far less noticeable. Or just be mindful of it when you're creating the angles. You can always, based on the length of it or based on the angle, you can go ahead and customize the mesh that spawns. That's going into a little more complex stuff. Just know that this is a thing, keep in mind. But fantastic, we have these now. So now we want to get the actual planks in between all of these. So how do we do that? Well, first we need to figure out, well, how many do we even need in between these? Because how do you even judge that? Because not all of them need the same amount. And we could do that by just creating splines on every single one of these poles and telling it to generate based on distance. So that way, the amount of points on a smaller spline would be less, and the more ones would have more, of course. So how do we create a spline for every setup here? It's actually relatively simple. We're going to take from these merge points and the world raycast, which is the top and bottom points here, and we're going to combine them. So we'll take another merge points, and we'll take it from the original merge points and the world raycast here. So if I debug that merge points, you'll see it is the tops and the bottoms of all these points. Fantastic. But now I need to separate these out, because if I press A, you'll notice it's all under one piece of data. I want every single pillar, every single one here, to be its own separate piece of data, so that way we can create a spline from each one. So this won't work just right out of the bat. Before I project the points downwards, I'm going to add an attribute to it, which is basically its index. By saving the information as a separate attribute, when it's projected down on the next node, which in this case is world raycast, it will also have the exact same information. So we'll have two sets of points, one at the top and one at the bottom, that both have an identical attribute. So go ahead and take all of this, just drag it over to the right. And again, we need another set attribute node. So we'll duplicate it over, plug the merge point into that, and re-plug in the set node back to everywhere. So on the set node, we need an in A and an in B, both from the merge points. It's going to throw an error, but don't worry, we just aren't set up yet. For input source 1, I'm going to set it to be the index. So just $sign index. And input source 2, it'll also be the index. Take it from the index to the index. Well, that doesn't do anything because nothing has changed. And you cannot store something onto the index, which is why we're just going to change the output target here to indexes. So basically, we're just storing the index value onto indexes. And if I press A here and I scroll to the right, you'll see indexes is there it is 0, 1, 2, 3, 4, 5, 6, 7, and 10. It continues on exactly the same as the indexes actually. So fantastic. We have that here. And when we go onto world raycast, if I press A, also has the indexes there. It now also has the impact distance, which we're using. The indexes have connected through, which means on this merge points, it is still all there. Not only that, but if we take a look, this is going down in number, and then at a certain point, the value resets because it is going top and bottom. So now if we use an attribute partition, we can partition it by that value. So let's go ahead and open it up and change the act last here, indexes. And now if we press A here, you will see we get just 2 points, and there's all our different columns. Fantastic. Which means from here, we can just use a create spline node and then a spline sampler. And let's say we want it by distance every 500 units in height. That's going to be great for us. Now, just like the previous one, we're going to turn on unbounded because again, we don't have a volume. So we'll turn on unbounded here. And then if I go ahead and grab a debug node, we'll set it to be absolute. Now let's change the point scale to something like 1.5. You will see, hey, there's all our points. Every single one of these now has points going down in increments of 500. Well, that's pretty good. That is working relatively well. Here's the thing though. If I press A on this debug and I select a random set of data here, this time 137, if I look over to the indexes, for some reason, these are not the same. If I pick a different one, again, not the same. Go to another one, again, not the same. The first one is the correct one, but the ones afterward, for some reason, are one lower. But if you look at just 0, well, 0 is correct. But for some reason, after the first one, they all stop matching correctly. So we need to reset this properly again. So from the spline sampler, once again, we'll use a set attribute node, just like the ones above. And then from this attribute partition, we're going to drag out, search for get attribute from point index. The attribute we're going to get is indexes, because that's the one we're fixing. And it's only going to grab 1. And that's perfect, because we can just go ahead and set that here, because we're going to replace all of them in that data set with the 1. So on the set node, we'll just take indexes as our first set, and then and press A. And now if we select any one of these, you'll see they all have the exact same index number. No matter which one I select here, they all have the same one, which is what we want. Perfect. I don't know why it changes them, even though it's creating spline path correctly. Easy fix. If I debug it one more time, you will see it's all correct, but there's one problem. They're all facing kind of not the right way. Like this one's angled, this one's facing one direction, the top ones are not facing the correct direction at all. We need them to face the same direction as the actual splines on top. So we can use the original information to reset them based off of the spline. All we need to do is reset the information from the rotation from the original before we created the spline, because the spline has overridden the rotations. So I'll grab another set attribute node, and I'll go ahead and grab another get attribute from point index and plug the attribute partition into that. And on this one, I just want to grab point rotation, and I can plug the attribute into the set node. It's going to complain, but that's because we haven't changed at last here for input source 1 to point rotation. And if I go ahead and debug this one, and we take a look, you'll see that, well, they look pretty much the same. So what's going on? Why did it not copy over? Well, that's because in our get attribute for point index, we're using index 0. If I set it to be index 1, you will see that, well, the rotation now makes a little more sense. Okay, so hold on. Well, why is this? And also, why is the points always on the bottom here? Well, it's because we plugged it in the wrong order. The order at which you plug in the merge points does matter. Now, I plugged in randomly and backwards to show you that order does matter here. If you're in 5.6, you can just click an add new pin and you'll have an exact in1 and in2. What we want is the world raycast one to be in2. The second one plugged in here. If you're in a previous version, you'll just plug it both of them in to in, but the world raycast will be plugged in second. And then with this attribute from point index set to 0, you'll see now we're getting more of what you would expect, which is the original points up top all matching. And you can see all of the points below also match the rotation that you're having up above. If you don't want this, you could of course not copy over the rotations. In terms of the pitch and roll, you can just grab the yaw, for example. I like the effect that this gives, so I'm going with this one. But fantastic, we have all the points, and again, nothing is below, so great. But we're still stuck with the original points up here. We don't want these points. Thankfully, it's very simple to filter them out. Using a simple point filter or an attribute filter, either one, because they're basically the same node here. We will keep it on greater. We'll change the target attribute to be index, and we'll set it to a constant number of 0. As long as it is greater than 0, basically, as long as it's not the very first point, keep it. So from here already, I can just drag out and search for a transform points node, and I'll scale it just a little bit shorter than 5 here in X, which is the length of it, so 4.8. I'll turn off uniform scale, and I'll make it thinner in the Y and a little bit taller, so it's a little bit more of a vertical one. So that's going to be our scale, and I'll also offset it by basically half of this distance. So this 480, so this is going to be offset 240 in X. At this point, static mesh spawner, and I'll plug in our cube, and this is the one that is going to be from the bottom pivot. And if we take a look, there you go. There's our path. There it is, all connecting. There's one problem with this though, and it might be hard to tell depending on the setup you've actually drawn out for yourself here. But if we go here, you can see, well, they're not quite lining up. This one is not angled properly to the next point. In fact, if I go ahead and just make a sharp turn here at the very end, you will see that these last points really do not connect. So really what we want is each point to angle towards the next one. So whatever this point is, angle it towards the point, not to where the spline was. And thankfully, that is actually relatively easy to do with just 2 nodes. You can make all your points follow a path, 2 nodes required, easy peasy. Let me show you. Because it's all using the same rotation all the way of the points originally, we're actually going to do that all the way back here. We're going to make these points follow each other correctly after we have offset them. We're going to take all of these nodes and just scooch them over to the right so we have more room. And from these transform points, we're going to drag out and search for create spline. And on this create spline node, I'm going to make sure it is set to linear. And then using a spline sampler node that is set to subdivision of a value of 0, it is only going to effectively change the angle of the points to face the correct direction based on the new spline. So if I go ahead and just take this and duplicate it for the one below, and then plug both of those in again into the merge points, we'll be almost done. The only thing is to not forget to, because it's very easy to forget, is for both of these spline samplers, turn on unbounded. And then you will see, hey, well, that looks a lot better. That goes pretty much much right in the middle, doesn't it? It is now facing the next point. And if I go ahead and angle this again very sharply, which again does not really work great, it is facing the correct way. You can see it is not long enough to reach it because in this scenario, it just needs more length, but it is still facing the correct way. Now, for a roller coaster, this is not a problem because you're never going to have such steep turns. But if I just make this a little bit less steep, you can see here, it is now again facing the correct way. And you can see they're not quite connecting all the way through. We can go here and increase the scale here, let's say to 5, and change the offset to 250. And now it connects a lot better. Again, based on the angle, it might need a little bit more, maybe like 5.2 and 260. And there you go. Now it's connected. But the main thing is they're all facing the correct way from the center to the center, pretty much all the way around. So very easily, effectively, you can do this for anything. If you ever need points facing into each other directly after an offset or for any number of data assets, create a spline, set it to linear, and use a spline sampler of subdivision 0. That takes care of all the facing for you. And I won't do something like if you have a bunch of points and you want to face a single location, that's different. But if you want them to just face each other in order, easy solution. Now, just for myself, I am going to tweak one other thing, which is the start here. I don't like the fact that this starts a little bit past where these planks and start here is. In the plank track here, I'm going to offset the start by 50, which is half of the size of the cube. And also down here, I'm also going to offset it by 50, which is the area below. So if I go ahead and select all of this, you can just comment it to be supporting structure. And you can see it now a little bit better connects here. So now we can have this go all the way around wherever we want, connect it down, connect it up, change the angle if we wish. Just careful not to put it way too low into the ground. And there you go. There's our track. I think looking pretty nice. And because each side is independent in terms of its calculations effectively, it is very simple to just take it, rotate the actual curve here, and all of the pillars, all of the supports, everything adjust accordingly. And if we just adjust the lighting and some depth of field, you can get some really nice effects here. There you go. That's how you create this entire system. You can of course go in and add more supports now, same way as I did before. The main thing I want to show you is that this is relatively simple to do. Create a spline, have the spline create other splines because you have raycasts to go from one point to another, use a distance from there, put it all together, and you got yourself basically a roller coaster base. And because the actual roller coaster here is just the body, but it does have a spline, just through blueprints, you can just attach something to that spline and have it move along it, and you have the full setup. Now, as always, if you want to play around with this project for yourself, it will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join the community, the link to the Discord and everything else will be down below as always. And if you're looking for more awesome tutorials on Unreal Engine, check out this one right over here. It's one of my favorites.